Good morning, everyone. Nice to be with you. I'm Dinos Panidis. I'm the CEO of Hydrocom. Hydrocom specializes in management information systems for utilities, municipalities, and certain government institutions. It's a company over 30 years old. We have presence in more than 20 countries and major customers, more than 200 utilities. Today, I will concentrate on water and sanitation utilities. As my title says, I will focus on integrated asset management using GIS for water and sanitation. Apologies for this. I think we're on right now. As an introduction, I will start by looking at the current challenges for asset management in China and our respective approach with regard to water and sanitation. Annual investments in water and sanitation infrastructure in China amounted to more than 500 billion yen over the last few years. That's on an annual basis. They're expected to increase due to China's plans to address water pollution, secure its water supplies, and reduce degradation of its infrastructure. As a result, we've seen through various publications that Chinese utilities are starting to realize the importance of improving their asset management and operational management practices. We believe that the best way to face this challenge is the introduction of best practices in integrated asset management. Hydrocom has joined hands with Supermat to provide innovative GIS-based integrated asset management solutions specifically designed for water service providers. The presentation looks at available technology, best practices, and the practical approach towards building capacity for asset management. We will briefly deal with all the components of asset management. The contents of my presentation. We will start by looking at the historical understanding of asset management and the current approach. We will have an overview of the proposed methodology for implementing asset management practices. We will briefly describe all the required asset management practices and corresponding information systems. We will also go through 3 different case studies of projects executed in asset management with 3 different approaches that meet the requirements of different types of utilities. We will finish off by summarizing the benefits of asset management. What is asset management? Prior to the 1980s, asset management was limited mainly to reactive maintenance. Something broke, and we ran to fix it. In the 1980s, preventive maintenance commenced. People would monitor the condition of an asset, and in anticipation of failure, took appropriate measures. Since 2014, the approach has changed. People started managing their assets and used the reliability risk-based approach for maintenance. Appropriate standards were introduced, like the ISO 55000 standards. In this new approach, performance played a very important role, both for the asset and the utility as a whole. As a result, in our company, we've adopted the following international definition for asset management: an integrated approach to monitoring, operating, maintaining, upgrading, and disposing of assets cost effectively while maintaining a desired level of service and improving overall business performance. This slide gives you an overview of the proposed asset management methodology. It involves 3 stages. During the initial stage, an assessment of the organization is carried out, followed by strategic planning. The main stage is where all the relevant asset management practices are implemented. The final stage is the stage where an evaluation improvement system is implemented. We will look briefly at each stage separately. The initial stage. In the initial stage, a review of the utility is followed by data analysis and evaluation, all leading to the compilation of what we call the asset management framework. Basically, a document that will define all the actions to be taken. Furthermore, an asset management policy has to be formulated, and commitment on such policy must come right from the top in senior management. And level of service goals must be defined in line with what the stakeholders, customers, and employees can expect. In the final stage, an evaluation improvement system must be implemented that must include monitoring and measurement, performance evaluation, non-conformity and corrective actions, preventive actions, and continuous improvement actions. Such a system must be applied to continuously monitor and evaluate the performance of both the utility and the asset management process itself. And now the main stage, that of asset management practice. Asset management practices in the technical departments are basically in three groups. The fundamental group is data management using GIS to maintain the asset register. Everything else is built on that. That's the important, the GIS. The second group of activities or best practices falls under operations and maintenance. The third group under planning. Operations and maintenance includes maintenance management, operations management, water quality management. Whilst planning includes asset management planning, infrastructure planning, that's where things like modeling comes into hydraulic modeling, and business planning, which is effectively investments and financial planning. It should be noted that all these proposed systems and asset management practices must be implemented in a coherent manner where proper project management, including risk analysis and change management, is taken into account. Also, it should be noted that a single data model must be employed so that it would allow interdepartmental integration and demand management functionality. For example, information of billing systems must be fully integrated with information of the GIS and technical asset register to enable things like demand. Also, the technical system must integrate with the utilities financial and procurement system to address the financial functions of asset management, as well as telemetry systems to enable the system to receive information. We will look at each one of these functions or systems if you want to. Every single one of these asset management practices, best practices I described, is accompanied by an appropriate system, what we call the EDAMS systems, which is the EDAMS is the proprietary software of our company. Use of GIS. As I said before, we have recently joined forces with Supermarket to provide fully integrated GIS-based solutions for utility management. You all know Superman, so I won't describe it. By now, all our products are fully integrated with the Superman product. Let's start with the basic block. The EDAMS-Data management system is an industry-specific asset register and network infrastructure management system. We'll describe it by looking at the different building blocks making up the system. The system has provision for all the standard assets in the areas of water supply and sewer distribution, production and treatment. Data quality standards and procedures are built into the system. The EDAMS LIS, Land Information System, can manage and maintain topographical and land passing information, such as plots, buildings, and properties. Powerful data conversion and structuring facilities exist, making it easy to convert data from various sources and untouched engineering intelligence tools. Element libraries simplify and enforce discipline capturing of all relevant topics. Data analysis and cleaning is streamlined and automated with missing attribute data, connectivity, or topological violations, and suspect engineering zones highlighted as exceptions in terms of criticality. Reports and maps are possible in various formats to enable appropriate field investigation. Weapon field operations are possible for the field investigations and validation. Web publishing is possible, enabling online viewing, query, locating, map production, and reporting. The maintenance management system. The main purpose of maintenance is the improvement of productivity and efficiency of the maintenance function, the improvement of service delivery, especially with regard to less breakdown time, and the collection of maintenance records, failure records, or condition assessment. We will have a look at its different components. The system is pre-configured with a predefined list of maintenance activities and data libraries as per industry's best practices. It integrates with the utilities HR, stores, and support services systems to have access to resources for work separately. Routine maintenance, preventive maintenance, and reactive maintenance are all enabled. The call center exists, handling requests as well as complaint management. Scheduling, workflows, and business processes are enabled and supported fully by web and field operations. Maintenance records and maintenance history enables tracking, viewing, and summarizing records to associate with that. Comprehensive management reporting at all levels, various forms to history, relating to history, work in progress, job costing, and employee performance. The system further includes comprehensive analytical tools, including failure modes and reliability analysis, leading to the compilation of proactive maintenance plans. Our next part is operations management. Operations management model, again, like the others, is built on top of the EDAMS-Data management model. Its main purpose is to ensure proper service delivery in terms of quantity and pressure, to operate pumps cost-effectively, to identify and localize and quantify system losses, what we call in the industry leakage. Again, we will describe the different components. Monitoring and control. The operations management module is interfaced with the different reading systems such as telemetry, data loggers, and other. The logs manager handles readings, measurements taken from any asset. Logs can also be generated from other logs using relationships or formulas. The bulk meter readings module enables and verifies bulk meter readings. The bulk meter analysis module classifies bulk meters in terms of their use and function. Production analysis calculates variable production costs in terms of all different types of variables, such as power consumption. Furthermore, production units are compared in terms of production costs to enable cost-optimized production scheduling. Pump performance is also evaluated both for configuration suitability in terms of energy consumption, as well as for pump motor efficiency in terms of design. Calculated overall efficiencies and be used as a preventive maintenance tool. Commercial data management. The asset management system is interfaced with the utilities billing system to read the billing data. Functionality includes the generation of problem lists, full consumption analysis, meter condition assessment, things like calculating whether meters are broken, faulty or slow, and calculation of demand that is very useful for further analysis, like balancing or forecasting for hydraulic modeling. zone management. The zone manager assists the utilities in validating, managing, monitoring, and controlling the zone. The system includes schematic zoning as well as tracing and routing. Dynamic zoning is allowed so as to be able to keep history of zoning. That's extremely important when you're doing historical analysis of mass balancing. Consumptions and demands can also be allocated to zones through GIS topology and the zone management. Non-revenue water management. The main output of non-revenue water management is the water audit, the leakage deduction program, for the purpose of reducing leakage in the distribution. Functionality also includes supply analysis, full leak tail analysis, minimum night flow analysis, real-time monitoring, raising alarms in the case of bursts. A comprehensive way of doing operations management. Excuse me. Water quality management, another issue that is quite a big issue right now in China. Main purpose of water quality management is to improve water service pollution in terms of quality, to ensure quick emergency action in case of contamination, and to ensure compliance with legislation. The system contains a LIMS, which is the Laboratory Information Management System, or can integrate with existing LIMS, as many utilities have different laboratories with their own link systems. Rather than focusing on a single sample, the model analyzes history and establishes trends, and it's ideal for reports for compliance with legislation. Functionality includes data acquisition, data management, includes a fully fledged metrology system. That's a system that handles very large amounts of information data and processing such data so it can be meaningful for further processing. Quality analysis and comprehensive reporting. Modeling and monitoring functionality includes emergency response management, even tracing the source of contamination, and even the drafting of emergency plans using the model. Just to sum up where we are so far in the presentation, we covered in terms of the asset management practices, the GIS asset registered part and all the operation and maintenance part. Now we're going to briefly look at the planning function. The EDAMS asset management planning system. Again, as you see, it's comprehensive, full of modules, and I'm only going to address the main function. Its main purpose is to minimize the cost of ownership of existing assets. In other words, extend the useful life of assets. Minimize the risk of failure, that is also improve reliability of the system. Maintain and improve the required level of service, and sustain the infrastructure in the proper working. The main output of the system is in the form of two plans: a rehabilitation plan that includes replacement, refurbishing, and a routine maintenance plan. Functionality includes condition assessment, importance assessment, asset valuation, risk assessment, all of them leading to full maintenance and rehabilitation plans. Infrastructure planning. Infrastructure planning involves the compilation of various plans. Number one is an upgrading plan. An upgrading plan is extremely important when distribution system that becomes what we call in the industry a spaghetti network, where things are not properly functioning and properly solved. The DMA implementation plan and commissioning is extremely important to be able to do management. An emergency response plan, a shortage and outage management plan, and a master plan dealing mainly with the major components of the system, like the main transmission lines, reservoir. To carry out all this work, hydraulic modeling is required. The EDAMS system has fully functional hydraulic models, both for water and sewage post-evaluation in this slide. The final planning function with that could be what we call business planning. Various information from all departments excuse me, and systems come together to produce investment plans, as well as a detailed financial plan with forecast on profit and loss, cash flow, balance sheet, and financial. Business planning enables providers and funding organizations to assess the performance and sustainability of the utility's future operation and its ability to repay. This slide summarizes all the components of asset management proposed methodology as we discussed. The next couple of slides describes the EDAMS systems that form part of the final stage, that of evaluation of it. Management reporting, a set of standard reports are designed for each business function. They are structured in such a way, excuse me, they're structured in such a way so as to provide operational, middle, and senior management, as well as stakeholders to provide reports. Such appropriate management information enables taking proactive, corrective action. Business intelligence. This slide illustrates the architecture of the EDAMS-Business intelligence software. EDAMS-Business intelligence system analyzes and prepares the data, utilizing the EDAMS integrated data. Basically, irrespective of what software the utility has, we integrate all their software into our model, so we can do further analysis and processing of the data, so we can come up with a proper business intelligence model for the utility, including reports, dashboards, active schematic mapping, and so on. This is an example of a dashboard from one of our customers. I think this is Mombasa, Kenya. Case studies. The following slides describe briefly 3 different case studies of projects executed in asset management in different ways. I've chosen these case studies to show you that the approach can be effective, irrespective of whether of the type of utility. So I'll show you 3 different ways that we implement. The first one is about SEEAM. SEEAM stands for Southeastern Europe Asset Management Program. The program includes the use of the EDAMS asset management software through the cloud, together with training and support. Asset management solutions are systematically introduced to participate in utilities through key sessions. This is a 5-year program currently running in 6 countries. It's carried out jointly by Hydrocom and GIS. Basically, we have a strategic partnership agreement with the German government for carrying out this program. We're implementing it in 3 different stages. The silver stage deals with GIS and network data management. The gold stage deals with maintenance management. The platinum stage dealing with asset management planning and operation. This program is mainly focused towards small to medium-sized utilities that are not very wealthy. They can't afford to buy their own individual software. So or you can't afford to pay for full implementation of the software on an individual basis. So the implementation is done on a regional basis, on a group basis, and works out. 122 utilities are already participating. The next case study is that of Lusaka Water and Sanitation Company, that's the capital of Zambia. Further to supplying all the EDAMS asset management solutions, we've completed recently, in joint venture with Silica Veolia, French company, people in the industry know well, an 18-month contract on asset management technical assistance funded by the Millennium Challenge. The project provided transfer and practical support to the company with emphasis on capacity building for the proper operation of the EDAMS I'm happy to report, but by now, more than 50 users are effectively using. The third case study presents a different approach that was chosen by the client. The client being Nelson Mandela Municipality. That's the 5th largest municipality in South Africa. After implementing the EDAMS systems, the municipality decided to outsource asset management support services. They themselves have more than 100 users on the system. For the last 8 years, the system is being supported by in-house hydrocompressor, and that ensures proper operation and maximum system efficiency. So 3 different approaches for 3 different types of customers. Obviously, the richer customer is the last one to see. They're even paying for insourcing of the services. And finally, my last slide sums up in a group way the benefits of asset management. We have improved management, better services, financial benefits that are manifested in terms of increased revenue and reduced production costs, higher credit worthiness for the organization, and better compliance and transparency. Thank you very much. Thank you for putting up with me and your patience.